Today I will talk about the switch division fabrics for the switching system. And the topic divided into the two parts. One part is single stage switches, and the second part is multi-stage switches. So let's talk about the crossbar switches. One of the single switches. There are several cross-point selectively enable the I/O communication and is feasible to implement in very large single integration. There are several advantages. Overall, there are also some disadvantages such as scalability and the number of cross-point may increase competitive loading and slow transmission, and there are also no fault tolerance. So face the problem of these switches can suffering output port blocking. So how to respond to it? There are three directly method. The last one later we will talk about in the next slide. So the first method is a knockout switch. But the most important thing is to think how to reduce output port buffer capacity to make the system more efficient. So this method decide which input get buffer to try to deal with the problems. It's a structure about knockout. Firstly, there are 8 input pass through the packet filter, and then they are competitive with each other, and and then the four winners will have the choice to establish a connection with a specific output. One of them just pass through the output, and another three will spread load and then go inside the buffers, waiting for the next match. About another method, arbitraging, they can try to deal with the problems for multiple input for one output. And in addition, we should charge the performance, fairness, and the cost. So there are two generic method, PIM and ISLLP. ISLLP is more convenient than FIFO, cause each time slot or round they can transmit they can connect three connections. But in terms of it, PIM example is much smaller than it, because for example, when the three ABC input give the request for the output, each output will give a grant for each input in the first round together, instead of just show a grant one by one in the ISLIP example. So let's move on the multi-stage switches. They are composed of networks of single-stage switches, and so that makes a few cross points in it, and the diversity of pipes will also slow the block and increase the reliability of this system. So one example is clock switches. There are many advantages, and the user path diversity can fewer cross point than the crossbar. The cross point NX are showing below. So how to optimize the value of the N and K to make sure the system won't block or is arrangeable non-blocking. So the range of the K can be calculated using a mathematical formula. And another example is buy-in switch. Uh, the different from the clock switch is the number of the output port can be changed into the bit, but and overall they can multicast the packet anymore. So but the cross point is smaller than the crossbar. But there are also some drawback, because they will suffer from the potential of block and typically limited to packet switching. And the output port 0 means turn left and 1 turn right, so the connection just like this.